Okay, here we are at section 3.3, measures of relative standing and box plots. We want to understand how numbers relate to other numbers within a data set and how they relate to the mean. So we're going to learn about z-scores, we're going to learn about percentiles and quartiles, and also about the graphing of a box plot. Okay, first of all, z-scores are very important and they will appear again in chapter 6. Here is the definition for z-scores. Z-scores, or standardized scores, do not have a unit of measure. Basically, what you're going to do is take the data value, subtract the mean of the data, and divide by the standard deviation. Z-scores are considered significantly high if they are greater than or equal to +2. And z-scores are considered significantly low if they're less than or equal to -2. So negative z-scores are always less than the mean, and positive z-scores are greater than the mean. So let's see if we can answer this question. In this case, we've got our number of siblings for our 23 members of our class, and our pulse rates for the 23 members of our class, and they don't really have anything in common. The units of measure aren't the same, but we can determine which one is more extreme. Excuse me. Which is more extreme, the maximum pulse rate of 85 or the maximum number of siblings, which is 6. So we're going to use z-scores to determine this question. So let's find the z-score for the maximum number of siblings. First, we need to find the mean. So we're going to say equals average. We're going to select our data set of siblings. So I need to fix that. When it says circular reference, what it is I accidentally selected the box that I want the reference to go in. So I had to go from K3 to K26, find the average. Okay, the average is 1.96. Now I'm going to find the standard deviation. And I'm just going to do a standard deviation of a sample. These are all things I need for my z-score. And then I can find my max by saying equal max and just make sure that it is and the max is 5 of siblings. Okay, so that needs to change to 5. Okay, all right, so let's find the z-score for the maximum number of siblings. We're going to do the data first, which is going to be, I'm going to say equal, and I'm going to say the maximum data value minus the mean of the data set divided by the standard deviation. And our z-score is 2.4. So that's definitely a significantly high value. Okay, now we'll go to the pulse rates. We'll find the mean. Circular value again. M3 to M26. Okay, mean is 75.5 or 75.6. We'll find the standard deviation and we'll call it standard deviation of a sample. Select our data. We'll find the maximum. So notice there's nothing about these data sets that are similar, but let's find the z-score for the maximum pulse rate. And remember, z-scores do not have a unit of measure. Siblings in people is the unit of measure. Pulse rate is in beats per minute, but z-scores do not have a unit of measure. We'll do our data value minus our mean and divide by the standard deviation. Okay, so they're very close. They're actually very close. And usually z-scores are rounded to 2 decimal places. So I'm going to round that to 2 decimal places here and here. And as you can see, the larger z-score is actually the z-score for the pulse rates of 2.43 as opposed to the z-score for the maximum number of siblings, 2.41. So in the data above, which maximum is more extreme? The maximum number of pulse rate, the maximum pulse rate, or the maximum number of siblings? And in this case, since the z-score for the pulse rate is higher at 2.43, we will say the maximum pulse rate of 85 is more, 85 beats per minute is more extreme than the max number of 5 siblings because the z-score 2.43 is greater than z-score 2.41. So you can compare data values that way. Okay, let's look at percentiles. Percentiles are another measure of location of a data value within a data set. Here is the definition for percentiles. Basically, the percentile is going to divide the data set into 100 groups of 1% each. So in the notation P2 here would be the second percentile, that is 2% of the data is below this data point. Or P50 would be the median because 50% of the data would be below P50. If you want to find the percentile for a particular data value, you just find a percent. It is the number of values less than the data value x divided by the total number of values times 100, and that gives you the percent. So here we have the sibling list from our class, and the question given is find the percentile corresponding to 2 siblings. Well, first we need to find the number of data values less than 2. And so first thing that I did, I went ahead and sorted these data values from lowest to highest. And I went ahead and did a count of all of the data values less than 2. And there's actually 12 people in our class that have 1 sibling. So the number of values less than 2 is 12. Dividing by the total number of values in this case is 23, and times 100. So when I follow this formula, which is 12 divided by 23 times 100, I'm going to get 52.2, and sometimes percentiles are decimals, and we'll round to 1 decimal place. And so we would say that the percentile corresponding to two siblings in this set is P 52.2. Okay. A quartile, so a percentile divides the data into 100 parts of 1% each. A quartile divides the data into 4 groups of about, you got it, 25% in each group. And so we could say that P25 is the same as Q1, P50 is the same as Q2, which is also the median, and P75 is Q3. Let's look at percentiles from a different angle. So if you want to find the number corresponding with a certain percentile. So here we have the same list of the number of siblings, and we want to find the number of siblings corresponding to P25 or the 25th percentile. Well, we're going to sort the data first. Here I've sorted it in descending order from highest to lowest. And then we're going to find what we call a locator. This L is a locator, and we're going to compute the kth percentile. So we're going to do the percentile we're interested in, k over 100, times the total number of values. And then we look, and if k is a whole number, then we'll do the kth percentile is midway between the nth value and the next value of the sorted data. So we're going to take the nth value and the L plus 1 value and add those together and divide by 1 if k is a whole number. If L is a whole number. If L is not a whole number, we're going to round L up to the next largest whole number and use that, counting from the lowest, as our nth value. Okay, so let's try to find L for the 25th percentile of siblings. Okay, our total number of data values is 23, and the percentile we're interested in is 25. So we're going to go ahead and calculate L using this formula. And I did it here. I said 25 divided by 100 times 23. That's this formula right here. Okay, and when I did that, my L was 5.75. And so that is not a whole number. So I'm going to go down here. It says change L by rounding it up to the next larger number. So even if this was 5.25, I would round it up to 6. Okay, so this is going to be 6. L is going to be 6. Now it says the value of Kp is the nth value, which is the 6th value, counting from the lowest. So I'm going to count 6 up. 1, 2, 3, 4, 5, 6, and I'm still at 1. So I'm going to say that my P25 see if I can get down here. I'll put it right here. My P25 is equal to 1 sibling, because that is the 6th value counting up from the bottom. Okay, so that is how you can find the percentile of a certain data value. Now, P25 is the same as the first quartile. So that is the same because 25% is 1/4. Okay. All right. Well, one more thing in 3.3 that I want to show you is the 5-number summary and the box plot. Box plots really help us graph the spread and also to summarize the data. And they help us to compare different data sets that have different means and standard deviations. So here I have pulse rates for men and women, and I think there's 25, 40 in each set. The 5-number summary consists of the minimum, the first quartile, the median, the third quartile, and the maximum. And then the interquartile range is going to be Q3 minus Q1. So all of these things can be found quite easily using Excel. I went ahead and found the them for the women. Here's the minimum for the women in this list. The first quartile was at 70. The median for women, 76.5. Q3, the maximum. And then the interquartile range was just Q3 minus Q1. Okay, I'm going to go ahead and demonstrate how to find these for the men. You just say equals. If you want to find the minimum, you just start typing men. And then you would select the data. Quite a few pulse rates here. And the minimum for the men is 46. Now for the quartile, there is a quartile function. So I'm going to type quartile. I'm just going to, the regular quartile function there, and select my data. I'm actually going to hit Shift and go down and select A41, and that selects all of it. And then you want the first quartile, so I'm going to say comma 1. So my first quartile for the men is 60. Okay, let's do the median. You can do quartile 2 or you can do median. I'm going to do just median for this data. Again, if you hold down the Shift key and select your last box, that selects all of them. That's a nice way to do it. Median is 67. Okay, let's do another quartile. Quartile 3. So we'll select our data. Comma 3 for the third quartile, where the 75th percent is actually 75.25, and we need the maximum for the men. So we'll select the data. Okay, and the maximum is 89. So let's go ahead and find the interquartile range. That is the maximum minus the minimum is 43. Okay, so there you have your 5-number summary. That doesn't include the interquartile range. So this right here is the 5-number summary for the men. Okay. Now, in your Blackboard, there is under helpful sites, okay, so helpful sites, there is a box plot creator, and I already created the box plots for this data, and what I did was I cleared my data, and I wanted to create 2 different box plots. So I just copied and pasted the data for the women in here. Now I did have to put comma W after each data value, so that took some time. And I did want to graph by category. If you want 2 box plots, which is very common that you'll see two box plots to be compared, then you'll want to graph by category. So I selected graph by category, and I pasted the women in here and put comma W after each, or I could have put comma women, but I put comma W. Then I pasted from Excel the men's data in there, and I put comma M after each one of those. Okay, and it just created these nice box plots for me. Now, a box plot or a box and whisker plot has the 5-number summary drawn as a box, where my minimum is going to be this left whisker. My Q1 is this side of my box. This is my median in the middle, and my Q3 in the right side of the box is Q3. So it's looking like for the women, the median is about 76, 78. And you can see for the men here in red that the median is lower than the women, sitting at about 66 or so. So you are kind of eyeballing it. So you have the minimum, Q1, median, Q3, maximum. And the box itself, the width of it shows the interquartile range. So we can see that the interquartile range for the men is larger than the interquartile range for the women, and that the women just appear to have higher pulse rates than the men. Now, you can show the statistics if you click show statistics here, and it gives you the 5-number summary right here. The number of data points, which is 40, minimum, Q1, median, Q3, and max. I think that this is going to help you as you do your homework for 3-3. And if you have any questions, please bring them to me. On Monday, I will try to get well and be back to work as soon as I can. And again, the test for 1-1 through 3-2 will be on Monday the 19th. So work on your homework for 3-3 and any other homework that you have to get done, and we'll see you soon.